Hello everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 1, which is the pure mathematics one for October-November 2020, and the code is 9709/12. So let's move on to question number 1. Okay, so for question number 1, the coefficient of x cubed in the expansion of 1 plus kx multiplied with degree 5 of 1 minus 2x is 20. Find the value of the constant k. Okay, so now first of all, I will rewrite the question. And now when you look at these two terms, first term is basically with degree 1. So means that we are not going to expand it. We just expand the second term. So according to the formula, it will be a plus b to the power of n. Then this is a degree n plus nc1, a degree n minus 1, b degree 1, okay, plus nc2, a degree n minus 2, b degree 2 until b degree n. So this is the full expansion. Okay, so from here, since we are just interested to get the x cubed, and there is a 1 here, which means 1 must multiply with x cubed. So means that I need to expand this degree of 5 for 1 minus 2x up to x cubed. Then only I will get the coefficient. Alright, so which means here I will get 1 plus kx. Then for the expansion, when you compare, your a is 1, and then the b is minus 2x. Okay, so probably I will just rewrite first. This is 1 plus negative 2x, degree 5, so that you can see clearly the b is basically negative 2x. Okay, so then the expansion will be 1 plus kx multiplied with, okay, a degree n means 1 degree 5 plus 5c1. Okay, 1 to any degree is 1, supposedly 1 degree 4. But then for the next term, I'm not going to write this 1 degree 4 anymore, because that is always 1. Okay, so here you should notice that when here is 1, the degree for the second term is 1. Means that when I increase, it will be increasing as well. Okay, so then plus 5c3, then negative 2x cubed, plus dot dot dot, because this is the full expansion. Then from here, I will be getting 1 plus kx. Right, then just need to simplify the expansion now. So you will be getting 1 plus, okay, here supposedly plus 5c1 is 5 times minus 2 becomes minus 10. So therefore, I will change to minus 10x. And then the 5c2 minus 2 squared, it will be plus 40x squared. Okay, so bring in the squared to the x also, minus 2. Then for the 5c3, together with minus 2 cubed, you will be getting minus 80x cubed. Okay, so from here, right, so since we are interested to get the x cubed, so here I will just write coefficient of x cubed is basically this 1 multiplied with the term with the x cubed. So which means I will be getting 1 times minus 80. Okay, because coefficient means that the number before the x cubed. And then now, the other term is, here I have kx. So this kx to get x cubed, I must multiply with 40x squared. Okay, therefore it will be both plus k bracket 40. And now it's mentioned that it's given 20. So 20 equals to negative 80 plus 40k. Okay, so 40k equals to 100, because you move the negative 80 to the other side. Therefore, my k is going to be 100 over 40. And this will be simplified into 5 over 2. So this is the solution for question number 1. Okay, next question number 2. The first, second, and third terms of geometric progression are 2p plus 6 minus 2p and p plus 2 respectively, where p is positive. Now, find the sum to infinity of the progression. So for geometric progression, based on here, right, my A is 2p plus 6, and then my R, okay, my R is going to be second term over first term, so minus 2p over 2p plus 6. But then since you need to find sum to infinity, which means we need to find what is a p, okay, and it's same as the third term over the second term. This is the R. Then we are expected to get the p from this equation. Okay, so I will just do cross multiplication, right? So which means I will be getting minus 2p times minus 2p equals to 2p plus 6 multiplied with p plus 2. Then just do expansion, 4p squared equals to, now when you do expansion for the second term, right, remember to times to all the terms there, then you will be getting 2p times p is 2p squared. Okay, then 2p times 2, 4p. 6 times p, 6p. 6 times 2, it will be 12. Okay, so since the term on the left hand side is 4p squared, therefore I will move all the terms to the left side. Okay, then here I will be getting 4p squared minus 2p squared. Here 6p plus 4p will be 10p, so I will move to the other side because negative 10p. Then the 12 move to the other side is negative 12. Then from here it will be 2p squared minus 10p minus 12 equals to 0. And now just divide the whole equation by 2. Then you will be getting p squared minus 5p minus 6 equals to 0. And now you factorize this. Okay, so for your information, this quadratic equation can be factorized using two methods. This is the first method. Second method is using calculator. Okay, now to get p squared, obviously it is p times p. Okay, then to get the 6, it can be 6 times 1 or 3 times 2. Now, by looking at this is minus 5. Minus times plus is a minus. That means you should get the minus and plus. Then later on, the total of the middle column here is minus 5. Therefore, okay, because of the minus and plus, I should use 6 and 1. So here 6 and 1. And to get the minus 5p, it should be minus 6 and positive 1. Okay, because when I multiply 6 times minus 6 times p, it will be minus 6p. I multiply p with plus 1, it will be plus p. So when you expand, for the first column you multiply, that is p squared. Last column you also multiply, that is minus 6. So the middle column you plus, right? Here you times, here is plus, this is times. So when we plus together, minus 6p plus p is minus 5p. So I'm getting back the same quadratic function. Okay, so now from here, your final answer basically is just cross multiplication. So this is the manual factorization. Then I will be getting p minus 6 times p plus 1 equals to 0. Which means now either p minus 6 equals to 0 or p plus 1 equals to 0. Then now I'm getting p equals to 6 or p equals to minus 1. Okay, so now look at the question first. It's mentioned that p is positive. So given p is greater than 0, so obviously your p is going to be 6. Okay, right? So found the p, and then from here to get sum to infinity, just for your information, when geometric progression, right, first term is a, common ratio is r, sum to infinity is a over 1 minus r. Alright, so now I need to find out what is my a and what is my r. Okay, so I rewrite my a is 2p plus 6 now. So when p equals to 6, then my a is 2p plus 6. That means this is 2 times 6 plus 6, which is 18. Okay, then my r is going to be either you take the first one or the second one. It's up to you. So probably I will just take the first one, negative 2p over 2p plus 6. So it will be negative 2p over 2p plus 6. So it will be negative 2. 6 is p. Alright, p is 6. Over, now, for your information, this 2p plus 6 is our a. So I will just copy 18. Okay? So here, 18. That means you are getting negative 12 over 18, which is same as negative 2 over 3. So now, sum to infinity as infinity is basically a over 1 minus r. Then now you just replace. Your a is 18. 1 minus the r is negative 2 over 3. Okay, then from here you will be getting the answer. Then I will be getting 18 over 1 minus 2 over 3 is basically 5 over 3. So when you press your calculator, this is basically 54 over 5. So that's the solution of this question. Okay, question number 3. The equation of the curve is y equals to 2x squared plus m of 2x plus 1, where m is a constant, and the equation of the line is y equals to 6x plus 4. Now show that for all values of m, okay, all m, the line intersects the curve at two distinct points. So now here, when two distinct points means that, firstly, okay, because of the intersection, you need to solve two simultaneous equations. These are the two simultaneous equations. To show two distinct points, you are not finding the points, but to show that, just use the discriminant to show that it is greater than 0. Okay, so from here, I will write y equals to 2x squared plus m of 2x plus 1. This is the first equation. Second equation, y equals to 6x plus 4. Now, for intersection, right, that means solve simultaneous equation. And let first equation be second equation. So here, 2x squared plus m of 2x plus 1 equals to 6x plus 4. Okay, then from here, just need to do expansion because I need to get a general quadratic equation, which is in the form of ax squared plus bx plus c. So it will be 2x squared plus 2mx plus m. Then for the terms on the left side, just move to the for the terms on the right side, just move them to the left side. So here I will be getting minus 6x minus 4 equals to 0. And now I rearrange. Okay, so 2x squared plus, combine the term with the x first. That will be my term with x. Okay, so I will factorize the x and write 2m minus 6. Then followed by m minus 4. That will be my constant. Okay, so from here my a is 2 when you compare with quadratic equation or quadratic equation. Okay, so now my b is going to be 2m minus 6. Then my c is m minus 4. Okay, now you need to show that for any m, there will be two intersection points. That means we need to show that b squared minus 4ac is greater than 0. We want to show this greater than 0. Okay, b squared minus 4ac is basically the discriminant. Right. We need to show this value is positive. So here I will just write b is 2m minus 6. Then I square it. Minus 4, a is 2, c is m minus 4. Okay, so from here, alright, look at the question. For any m, right, that means your m can be positive or negative. Which means here, I will do expansion first because I have square of m, then this one I'm not sure whether it's positive or negative for the m minus 4. Right, so I will do expansion. So you do expansion using this formula. A plus minus b squared equals to a squared plus minus 2ab plus b squared. Okay, so now when it is minus, we just take the minus. Then this is going to be 4m squared minus, so 2 times 6 is 12, 12 times 2, 24. So it will be 24m plus 6 squared is 36. And now here, okay, this is minus 8. So you multiply with m, it will be minus 8m. And then now the minus 8 multiplied with minus 4, it will be plus 32. Then from here, you will be getting 4m squared. Now, minus 24m minus 8m. At last, you are getting negative 32m. Then 36 plus 36 plus 32, it will be plus 68. Okay, how do I show that this is positive? Now, I will complete the square. Okay, so complete the square means that I will perform the completing the square, means that you need to factorize the 4 first to make the coefficient for m squared as positive 1. So once I factorize 4, I will be getting m squared minus 8m plus, okay, 68 divided by 4 is 17. Okay, then from here, completing the square says that basically you are rewriting first two terms. I'm showing the step-by-step working. Then you always plus square of two terms. Plus and minus square of two terms. These two will be the additional terms. Okay, the term inside the bracket is basically the half of the coefficient of m. So that means here I will write minus 8 over 2. Then here also minus 8 over 2. Okay, because the coefficient for m is minus 8. Then now here, I will simplify. So I will group the first and third term. Okay, and it will be 4 bracket. Take the square out. So you will get m. Now inside the bracket of the third term, okay, it is minus 8 over 2. That is minus 4. So I will write minus 4 here. Right? Then now, for the other two terms, here minus remain. Then minus 8 over 2 is minus 4. So you square it, or probably I will just rewrite first. This is what you are getting. Then now here, rewrite the first term. And then now, for your information, all this must be combined. So minus 4 squared is 16. So minus 16 plus 17 is basically plus 1. Okay, then from here, I will just make the conclusion. So for any m, alright, m minus 2 squared is at least 0, because we know that whenever you square, it will not be negative. Okay, but when the m exactly 2, you are getting exactly 0. So then from here, m minus 2 squared plus 1, since minimum value for the square is 0, so when you plus 1, it will be greater than 0. Okay, so therefore, when you multiply with the 4 outside here, therefore, 4 bracket m minus 2 squared plus 1. This is definitely greater than 0 because you multiply with positive 4. Okay, hence, b squared minus 4ac is greater than 0 for any values of m. Okay, now, therefore, the line intersect the curve okay, when b squared minus 4ac more than 0 means 2 real roots. Alright, I should write here for all here implies two real and distinct roots. Okay, and distinct roots. Alright, so therefore the line intersects the curve at two distinct points. So shown. Okay, so this is the working. Okay, now question number 4. The sum Sn of the first n terms of arithmetic progression is given by this expression. Now the k term in the progression is greater than 200. Find the smallest possible value of k. Okay, now for your information, right, this is your Sn. You need to find out tk is greater than 200. Okay, so basically from here I can just find out what is my a and d, right? Because for geometric progression we need the arithmetic progression, first term is a. Okay, first term is a, then the common difference is d, so this d is basically second term minus first term. Alright, so then the k term is basically Tn is a plus n minus 1d. That's why I need to find out my a and d first so that you can find the k. So now you are given Sn is n squared plus 4n. So the first term T1 is the same as S1 because you have T1. So this is the S1. Alright, so that means you replace the n by 1 here, which is same as 1 square plus 4 bracket 1. This is 5. So I will say this is also A. A is 5. Because my first term is A. Now, my second term, S2, okay? S2 means that sum of the first two terms. That means it will be T1 plus T2. Okay, then from here, since my T1 is 5, so I will say, so when n equals to 2, 2 square plus 4 times 2 equals to T1 is 5, then plus T2. The purpose I get the T2 is I need to calculate what is my D. Alright, so from here, I will get 2 square is 4, 4 plus 4 times 2 is 8, so 4 plus 8 is 12. So from here, my T2 is 12 minus 5, which is 7. Okay, so from here, my common difference D will be T2 minus T1. That is going to be 7 minus 5. Then I will be getting 2. Okay, now since I have found the A and D, and now the question says K term is greater than 200. So which means now Tk is greater than 200. So for your information, Tn is a plus n minus 1d, which means now the n has been changed to k. So I will get a is 5, so 5 plus k minus 1, my d is 2, is greater than 200. And then from here I need to find out what is my k. So firstly, the 5 will be moved to the other side. So therefore, 2 of k minus 1 is greater than 200 minus 5 is 195. Okay, and then I divide by 2. So since you are dividing by positive value, no need to change the inequality sign. It will be k minus 1 greater than 195 over 2. 195 over 2 is basically 97.5. Okay, and now to get the k, just move the minus 1 to the other side, becomes plus. So therefore, I will be getting k is greater than 98.5. So now look at the question here. The k term. So the k term means that k must be integers. Okay, positive integers. And now you need to find smallest k. So since my k is greater than 98.5, therefore the smallest k, it will be 99. Okay, so that is the solution of this question. Okay, now question number 5. The functions f and g are defined by fx equals to 4x minus 2, x is real number, and gx is 4 over x plus 1, x is real number, but x cannot be minus 1. Okay, A, find the value of fg7. This fg7 is basically a composite function. Okay, so now first of all, I will find what is g7. So g7 is just to replace the x by 7. Then I will get 4 over 7 plus 1. That means this is going to be 4 over 8. Then that will be half. Okay, after that, I will get fg7. This is basically f of half because g7 is half. Okay, then now just replace the x by half. Then that will be 4 times half, then minus 2. So you just change accordingly. That means this is going to be 2 minus 2, and at last you will be getting 0. Okay, so that is the solution for A. Now part B, find the values of x for which the inverse of the f equals to inverse function of g. So right now we need to get both inverse function. So first of all, I will let y equals to fx, which is 4x minus 2. Okay, fx equals to 4x minus 2. Let y equals to 4x minus 2. Then from here, to get the inverse function, I'm using the method of getting x as a subject instead of y. So it means that I will move the minus 2 to left side. Then you will be getting 4x equals to y plus 2. Hence, your x is y plus 2 divided by 4. So now from here, the x will be changed to f inverse, and then the y will be changed to x. That is how we get the inverse function. Okay, now for the g inverse, I will let y equals to gx. Okay, whereby my g is 4 over x plus 1. So here will be y equals to 4 over x plus 1. Okay, and now to get the x as a subject, I will move up the whole x plus 1 and move down the y. Therefore, I will be getting x plus 1 equals to 4 over y. And then now, to get the x as a subject, the plus 1 will be moved to the other side. So x equals to 4 over y minus 1. Okay, then now from here, we can just get the g inverse. So the g inverse right now will be 4 over x minus 1. Once you have found these two inverse functions, just substitute into the equation. So f inverse equals to g inverse. And now we need to find values of x. That means it will be more than one x value. Okay, now just replace x plus 2 over 4 equals to 4 over x minus 1. Now to solve this equation, okay, for the right side, I will make it to the same denominator, which means for the 1, you just times x, then divide by x. Because I want to get x as a denominator, which means now I will be getting x plus 2 over 4 on the left side. Then for the right hand side, it will be over x. First term remains as 4. Second term, because 1 times x, you get x. Now, after this, just do cross multiplication. Okay, because we need to solve for the x. So now I will get x times x plus 2 equals to 4 times 4 minus x. And now you just need to do expansion. So for the left hand side, x times x, x squared. X times 2, it will be plus 2x. And then for the right hand side, 4 times 4, 16. 4 times minus x is minus 4x. Okay, and then now just move all the terms to the left side. I will be getting x squared plus 2x. The minus 4x move to the other side becomes plus 4x. Then the 16 move to the other side is minus 16 equals to 0. And now simplify the second and third term. You will be getting x squared plus 6x minus 16 equals to 0. Okay, and now this quadratic equation can be factorized into two factors. So it will be x times x. Okay, then this is plus times minus is a minus. So it means that you will have plus and minus sign. So the 16 I can check 8 and 2 because I want to get positive 6. So it will be plus 8 and minus 2. Therefore, plus 8x minus 2x over here. Okay, you will be getting x squared plus 6x minus 16. And then followed by cross multiplication to get the factors. So that means you will be getting x plus 8, x minus 2 equals to 0. When the multiplication of these two terms equals to 0, means that x plus 8 equals to 0 or x minus 2 equals to 0. One of them must be 0 in order to get products equals to 0. So which means my x will be minus 8 or x equals to 2. So this will be my x values because it's mentioned values over here. Okay, this is my solution of this question. Okay, now question number 6. A, prove the identity. So obviously, when you look at this identity, left-hand side is more complicated. Alright, because it has more terms. So I will choose to start from the left-hand side. So 1 over cos x minus tangent x multiplied with 1 over sine x plus 1. Then now for this, okay, because we need to get tangent later on, it's okay. I will just change everything to sine and cos first. Later on, I will change back. Sine x over cos x is tangent x. So, which means the tangent x, I will be changing it to sine x over cos x. Then 1 over sine x. Okay, now for the left hand side, I will make it to same denominator first. So which means for the 1, I will just times sine x and over sine x there. Okay, so it looks like this. So here I times sine x over sine x. Alright. Then here I will be getting over sine x because both are having the same denominators. So just need to write down the numerator. So it will be 1 plus 1 times sine is sine. Okay, and then now for the left hand side, since both also over cos, so now I'm getting the same denominator. So I will just combine that it will be 1 minus sine x in the numerator. Okay, and for the other term, it will be 1 plus sine x over sine x. Now, from here, the brackets means times. Okay, so you times the numerators and times the denominators separately. So now for the denominator, cos x times sine x, I will just write sine x cos x. But for the numerator, you can either do expansion 1 by 1, okay, or I will just use this formula. A minus b times a plus b is basically a squared minus b squared. So obviously my a is 1, b is sine x. Okay, then I will just direct apply this a squared minus b squared, which means I will be getting 1 squared minus sine squared x. Okay, you will be getting the same answer if you multiply 1 by 1, if you expand 1 by 1. So now, this is basically 1 minus sine squared x, because 1 squared is still 1. So I will ignore the 1 over here. And now, when you look at the answer is 1 over tangent. We know that tangent x is sine x over cos x. So if I take 1 over tangent x, it will be 1 over sine x over cos x, which means my answer should be cos x over sine x. Okay, I should get this. Now, when you look at the working rights now, I have sine square x. So which means I need to simplify it. We have a formula. identity sine square A plus cos square A is 1. Okay, so now from here 1 minus sine squared x, I will change to cos square x first, because when you look at the answer over here, this is my final form that I need to get. I should get just sine x in the denominator. But then when you look at our denominator right now, I have extra cos. Therefore, I need to change the 1 minus sine square x into cos square x, so that the cos x in the denominator will be cancelled off. Okay, that is the reason I use this identity. So now from here, I know that cos square A is going to be 1 minus sine square A. Okay, therefore, for the numerator, you will be getting cos square x. Then denominator is sine x, cos x. And now I can simplify. So cancel the cos x, numerator left degree 1. Okay, so that means cos x over sine x is basically, this is cos x over sine x, is basically 1 over tangent x. Okay, so done for this question. Okay, Nabi, hence means use the previous answer. Solve the equation. This equation exactly same as the identity on the left side. So I will just replace these two terms by 1 over tangent x. Then equals to 2 tangent square x for x from 0 to 180 degrees inclusive. So which means now I will just change directly. 1 over tangent x equals to 2 tangent square x. So now to solve this tangent x move up, the 2 move down. So tangent x times tangent square x is basically tangent cube x. Then the 2 move down, you get half. Okay, so now to get the x, the cube move to the other side first. So it means that tangent x is cube root of half. Okay, and then you get the answer of 0.7937 from calculator. So now look at the x domain. The x is from 0 to 180 degrees, means that it is in the first two quadrants. And by looking at this tangent, it is only positive. That means your angle is basically in the first quadrant. Because if it is in the second quadrant, it will be negative for the tangent. Okay, this is your angle. So that means now your x is inverse tangent 0.7937. That means in the calculator, it will be giving you 38.4. So that is the x value for this equation. Okay, question number 7. The point 47 lies on the curve y equals to fx, and is given that f prime x is this expression. Right? Now, a point moves along the curve in such a way that x coordinate is increasing at a rate of 0.12 units per second. Now, when you look at here, that means dx dt, because whenever you see rate, right, that is d over dt. Since it is increasing, that means it will be a positive. Alright, so I will get 0.12. Now find the rate of increase of y. dy dt is how much when x equals to 4. Okay, now basically to get this dy dt, we need to apply the chain rule. Okay, so chain rule, which is this chain rule, I will rewrite it later again. Dy dt equals to, since we need the dy on top, I will just write dy first, then times the dt at the bottom. So by looking at this expression, I should have dx, and then to eliminate the dx, it should be dx in the first term. Okay, so now which means I need to find out what is my dy dx. So this is my dy dx, but then we need to get the value. Okay, so that means replace the x by 4. Then you will be getting the value of dy dx. So now I will start with when x equals to 4, my f prime x, that is dy dx, it is 6 x degree negative half. So 4 degree negative half minus 4 x degree negative 3 over 2. So 4 degree negative 3 over 2. So from here, right, the first term is basically 3 when you press your calculator. Second term is half. That means you are getting 5 over 2. So now apply this formula, chain rule. So I will write dy over dt equals to dy over dx times dx over dt. So that is 5 over 2 multiplied with 0.12. Okay, then you will be getting 0.3. Now, when you look at here, the unit, dx dt, it is units per second. That means here is also units per second. Okay, so that's all for this part. Now B, find the equation of the curve. Okay, for your information, you are given f prime x. Okay, basically, if you are given fx, we differentiate, we get f prime x. But then, now you are given f prime x, to get back the fx, which is our curve equation, you are integrating it. Because the reverse process of differentiation is integration. Okay, so now I will rewrite my f prime x. F prime x is given as 6x power negative half minus 4x power negative 3 over 2. So 6x negative half minus 4x to the power of negative 3 over 2. Okay, so now I need to integrate. So your fx is basically integration of 6x negative half minus 4x to the power of negative 3 over 2 dx. Okay, this is your integration. Now, for your information, when you integrate ax degree n dx, whereby the a is a constant, you can just take out the a and integrate x degree n dx. So as long as the n is not minus 1, okay, so you can just use this formula. You always plus 1 degree to the existing degree, then over the new degree, and then plus c. This formula is valid whenever the n is not minus 1. Okay, so now by using this formula, I will get 6 times x degree. Okay, minus half plus 1 is half. Then over half. Then minus 4. The x degree negative 3 over 2, when you plus 1, the negative 3 over 2 plus 1 is basically negative half. Then over negative half. Then now, because of indefinite integral, which means the integration without limits, you have to plus arbitrary constant, which is a c. Okay, now simplify. 6 divided by half. Okay, 6 divided by half is basically 12. And then this x degree half, you can change to square root x. Now, minus is a plus. 4 divided by half is 8. So I will write plus 8. Now, you look at here. The x now with degree negative half. Whenever you see negative degree, you move it down. That means it is basically 8 over square root x. Because once you have taken out the minus from the degree, you get x degree half. X degree half is square root. So now here, 8 over square root x plus c. This is your curve equation, but we need to find the c now. Okay, so to get the c, refer to the given point, 4, 7. Okay, so now 4, 7, that means x equals to 4, fx equals to 7. So now when you replace, 7 equals to 12 square root 4 plus 8 over square root 4 plus c. So 12 square root 4 is basically 24, because square root 4 is 2, plus 8 over square root 4 means 8 over 2, you get 4. Then plus C, this is 7. Then from here, basically, your C is 7 minus 24 minus 4, that is minus 21. Okay, so equation of the curve. Just substitute back this C into your fx. It will be fx equals to 12 square root x plus 8 over square root x minus 21. So that is the complete solution of this question. Okay, question number 8. In the diagram, ABC is an isosceles triangle. Isosceles triangle means it is a triangle with two equal sides. Therefore, you are given AB is BC is R. Okay, these two are equal sides. And angle BAC is theta. It's given here. Theta radians. Now, the point D lies on AC. Okay, this is a point D. And ABD is a sector with of a circle with center A. Okay, this is ABD. Alright, ABD. This is a sector. Center A. Okay, now A. Express the area of the shaded region in terms of R and theta. Okay, so basically when you refer to this triangle, I would say that the area of the shaded region equals to area of triangle ABC minus area of the sector ABD. Okay, but now the problem is how are we going to get the area of the triangle? Okay, so now what I need to do is I will just, okay, you know that this is theta. Now I will draw a line, okay, and define this as the midpoint. So then I will find the AM, then I will find the BM, because I have the R and I have the theta here. I can use the right angle triangle, the sine cos tangent method to find the AM and BM, because you need to leave your answer in R and theta. Okay, so if I can find this triangle AMB, then I can find the whole triangle ABC. That means it's double of the AMB. Then I will minus the area of the sector. Therefore, I'm getting the area of the shaded region. So that's the idea to solve this question. Okay, now, firstly, I will define. So let M be the midpoint of AC. Okay, so then from here, if you want, you can just draw the diagram here. So this is the midpoint, M. This is a shaded region. Okay, so BC, A. This is theta. Here is R. This is R. Straight line. Okay, now to get the AM, okay, refer to the triangle AM. So now here, basically, when you refer to the theta, this is the adjacent side, and this is the hypotenuse side of the theta. So adjacent over hypotenuse is basically cos. Excuse me. So from here I will write cos theta equals to AM over AB. Okay, so now your AB is R, therefore AM equals to AB cos theta equals to r cos theta. Excuse me. Now to get the BM. Okay, so to get the BM, that is the opposite side. Which means if it is opposite side and we have the r, I'm going to use sine. So sine theta is actually BM over AB. Okay, so which means your BM is AB sine theta, which is BM equals to r sine theta. So now I can find the area of ABM. Right, so area of triangle ABM, that is half of, or probably I will just write area of triangle ABC, then better. ABC, that is double of area of triangle ABM. That means it's double of half. Now, I know the AM, okay, therefore from here I can find my AC. So my AC is 2AM, which is 2R cos theta. So I will write AC times BM. That is my area of the triangle ABM. Now, the 2.5 cancel. End up with AC times BM. So my AC is 2R cos theta. My BM is R sin theta. Okay, then from here is basically R squared cos theta sin theta. Alright? So okay, wait. I think I made a mistake. You see here, I wrote 2 of area of triangle ABM. Triangle ABM is basically AM times half of AM times BM. So I do need the AC basically. Sorry, mistake over here. Okay. So now I will write AM because double of the triangle. Or probably if you don't want to write double, then you just direct write half of AC times BM. Okay. So that means here it should be just R. Okay, mistake. Then at last, I will be getting just R squared cos theta sin theta. Okay, now my area of the sector. Okay, so we have a formula for area of sector. If let's say this is your sector with angle theta and the R is radius, so area of sector is basically half R squared theta. Okay, so now I will just replace. So area of sector, and our sector is ADB. This is D. ADB, that is half, say same formula because you are given theta and R. So R squared theta. So now area of the shaded region. That is area of triangle minus area of the sector. Okay, so this is your solution. Okay. Okay, B, in the case where r equals to 10 and theta equals to 0.6, find the perimeter of the shaded region. Okay, let's look at the diagram. Perimeter is basically DC plus BC, which is the R, then plus arc length of ADB. Okay, so now I will write arc length of the sector ADB is basically theta R. That is the formula. Okay, so replace the theta and R value, 0.6 times 10. I will be getting 6. Okay, now, next step is to get BC is R. Okay, just rewrite first. So BC is R, which is 10. And now I need to get what is my DC. Okay, so for information, since ADB is a sector, that means AD is the radius as well, which is R. And just now, I have found AM. So now I just need to find AC, then minus AD, that will be my DC. Okay, so DC equals to DC equals to AC minus AD. AC minus AD, where my AC is 2 of double of AM. Okay, so my AM is basically from the previous calculation, R cos theta. So here I will write R cos theta, and then I'll replace the R by 10. So 2 times 10 cos theta is 0.6. Then here I will just write in this form, 20 cos 0.6. Okay, therefore my DC over here is 20 cos 0.6 minus my AD is basically the R. Okay, the AD is R, which is 10. So that is my DC. So I will just count all this directly later on. Therefore, perimeter of the shaded region equals to DC plus BC plus arc length of sector ADB. So it will be 20 cos 0.6 minus 10. This is a DC. BC is 10. And then the other one is 6. Now when you calculate this, remember to set your calculator in radians mode. Okay? And then from here, basically, when you calculate all together, it will be 22.5. So this is centimeters. Okay, so done for this part. Let's move on to question number 9. A circle has center at point B, 5, 1, and the point A with coordinates -1, -2 lies on the circle. Find the equation of the circle. Okay, so from here, let's draw the circle and see the whole picture. Alright, so basically 5, 1 and -1, -2. That means, okay, let's say this is a circle. Right, center is here. 5, 1. So this is 5, this is B, 5, 1. Now when you look at the A here, the x coordinate is -1. So this -1 shows that it should be on the left side of B. And then the y is -2. That means it should be below the b. Alright, so let's say here is A. Right, so since the B is a center, now equation of the circle must be in this form. So x minus a squared plus y minus b squared equals to r squared, where the a and b will be the center, right? And then the radius is r. So from here, given the center is 5, 1, now I need to find the r. R is the distance of AB. So now, to find the distance, just for your information, let's say you are given x1, y1, b is x2, y2. The distance, which is the length of AB, is square root of x1 minus x2 squared plus y1 minus y2 squared. So this is the distance formula. Now, I'm going to use this to get my radius, r. So my r is square root of, or I would say r equals to AB equals to square root of, my x1 is 5, so 5 minus 1 squared, plus with my y is 1, so minus 2 squared. Okay, then from here, when you calculate, this is basically 6 squared, 36, plus 1 plus 2 is 3. 3 squared is 9. So you will be getting square root of 45. That is my r, radius. Now you substitute into this formula to get the equation of the circle. So equation of the circle, it will be x minus 5, because center is at 5. X minus 5 squared plus y minus 1 squared equals to r squared. So square root of 45 squared it. Then now, just simplify the right side. You will be getting x minus 5 squared plus y minus 1 squared. The square and square root cancel off. Okay, then you will be getting 45. So that's the solution of part A. Now, point C is such that AC is a diameter of the circle. Point D has another coordinate 5, 16. Show that DC is a tangent to the circle. Okay, now I redraw this circle. Let's say over here. This is my B. B with coordinates 5, 1 just now. Okay, my A is -1 and -2. So this is my A. -1 and -2. And now when you read the question, okay, it's given that AC is diameter. So whenever diameter, it must pass through the center, which means now, okay, I will just add up. So go through. This is my C. So my C, I do not know what is the coordinate. And then it's mentioned that the D has coordinates 5, 15. Now you see your B with coordinates 5, 1. And then now the D is same x coordinate. And then the Y value has been increased, right, from 1 to 16. That means it will be on the same level, the x level, but then probably your D. Okay, and show that DC is a tangent, which means I will have to draw a line. Tangent means the line just touches the circle as a point. And since this is my 5, my x is 5, most likely your D is same level of x, but then this is my D. Okay, so here is my C. So my D with coordinates 5, 16. So this is 5, 16. This will be my diagram. Okay, now you want to show that DC is the tangent. So whenever tangent means that the gradients of DC times by gradients of BC or AC, it will be -1. So I need to prove this. Okay, I need to prove M DC times M BC or AC, up to you, equals to -1. Okay, so from here, what I need to do now here is I need to find out what is my C. Okay, so obviously from here, the B is a center, the AC is a diameter, which means the B is the midpoint of AC. Alright, so C is the midpoint of AC. Oh, sorry, B is the midpoint. B is the midpoint of AC because, right here, because AC is a diameter. That's a reason. So diameter must passes through the center. Okay, so now my B with coordinates 5, 1, my A with coordinates -1, -2, then my C, let it be xy. So from the midpoint formula, alright, 5, 1 equals to x1 plus x2. So -1 plus x divided by 2. That is the formula for midpoint. Then the y1 plus y2 divided by 2. Now I just need to equate the equation. I just need to equate the x and y coordinates to get two equations. That means 5 is -1 plus x over 2. Then 1 is -2 plus y over 2. Here I will be getting the x and y. Then times or move up these two, move up the 2 as well. So I will be getting 10 equals to -1 plus x. Then this is 2 equals to -2 plus y. And now to get the x, just move the other term to the other side. Okay, so here I will be getting 11. And my y is 4. So with this, I found my C. My C is basically 11 and 4. Okay, so now look at here. This is the hint to solve the equation. So now I need to find MDC. Okay, D is given 5, 16. So D is 5, 16. C is 11, 4. So the gradient of DC. Now for your information, if let's say you are given 2 points, alright, gradient equals to the difference of the y divided by difference of the x. So here is basically 16 minus 4 over 5 minus 11. Then I will get 12 over minus 6, which is minus 2. Okay, now I need to find out what is my gradient of AC. So MAC, my A with coordinates -1, -2. And then my C with coordinates 11, 4. So now my MAC equals to 4 minus -2 over 11 minus -1. Therefore, this is 6 over 12. Am I getting half? Okay, so now I will just write MDC times MAC equals to -2 times half, which is -1. That means line DC is perpendicular. Perpendicular to the line AC. On other words, DC is the tangent. Okay, is a tangent to the circle. Okay. Now, the other tangent from D to the circle touches the circle at A. Touches means never cross, just touches, okay, at one point. Find the coordinates of E. Okay, now, what to do here is, look at the diagram. Okay, and now you need to add on another tangent from D. So obviously, right, I just look back this. So obviously I add one more tangent, so from the D, so now here, and it also touches. Okay, so when touches means that, okay, probably this is the D, this is the E, right? So from here, for your information, right, now when it is a tangent, here is 90 degrees. So this is the length, and here is also tangent, means that this is also 90 degrees to the radius. Okay, my diagram is not very accurate. Now for your information, okay, let me redraw. It should be just touches, so probably it is over here. Okay, let's say this is the E. Now for information, here is 90 degrees because it's tangent, both are 90 degrees. Okay, so from here you can just check, right? From C to D, okay, your D is 516, your C is basically 11.4, we have found just now. So here is 11.4. I would say that from C to D, okay, you can just go through here. It is from the X value is from 11 to 5. That means here is 6 units. Okay, this is 6 units. Right, 6 units to the left. It will be same triangle because both are 90 degrees. So 6 unit to the left, 11 to 5. Then for the Y unit, the Y coordinates 4 to 16 means that going up here, going up for 12 units. Right? So when you look at this, that means the C value, okay, when you need to get the E, it will be the same translation, something like translation. Okay, so it means that here it will be another 6 units. But then the Y value will be the same as the Y value. The Y coordinates of the E will be the same as the Y coordinates of the C. Okay, so from here, I will just write here because it's 2 marks, right? So point C is 11.4 to point D 5.16. So means that the X is minus 6, shifted 6 units, minus 6 units. Okay, then the Y is basically plus 12. So when the C goes to E, it will be moves 12 units to the left. Okay, and then the Y remains. Okay, which means now for the C, because right now your X coordinates is 11, so you move 12 units to the left, means that 11 minus 12, that is minus 1. This is the X coordinate. Okay, so I will write here X coordinate of point E. It will be 11 minus 12, that is minus 1. Okay, so therefore point E with coordinates minus 1 and 4, based on this diagram, okay, or based on this explanation. Okay, so no calculation at all. That's all for this question. Now, question number 10. The diagram shows parts of the graph y equals to 2 over square root of 3 minus 2x minus x and its minimum point m, which lies on the x-axis. Find the expressions for these three terms. Alright, so now, at first, your y is 2 over 3 minus 2x squared minus x. To get the differentiation or integration, we always move up the denominator. So I will rewrite y as 2 bracket 3 minus 2x to the power of negative 2, then minus x. Now, when you need to differentiate, okay, so differentiate fx to the power of n, we always bring down the n first. Then rewrite the function. After that, the degree u minus 1. And then differentiate the fx to get f prime x. Okay, so what I need to do here is my dy dx, I will keep the 2. Just for the degree of minus 2 for 3 minus 2x, I will bring down the minus 2 first, according to this power rule. And then rewrite 3 minus 2x. Okay, rewrite the whole function. The degree minus 2 becomes minus 3. And now f prime x means you differentiate the bracket. So when I differentiate 3 minus 2x is basically minus 2. And then last term, minus 1 becomes, minus x becomes minus 1. And now I simplify. So when you simplify, 2 times minus 2 is minus 4. Minus 4 times minus 2, positive 8. So I will write this as 8 times 3 minus 2x to the power of negative 3 followed by minus 1. This is my dy dx. So first expression is done. So for second expression, d squared y over dx squared means you differentiate second time of the dy dx. Or I would say I differentiate second time of the y, which is same as I differentiate one more time for the dy dx. Then from here, again keep the 8, bring down the minus 3, rewrite the function. Then the degree, instead of minus 3, now you minus another 1 becomes minus 4. And do not forget to differentiate the bracket. So when you differentiate the bracket, 3 becomes 0, minus 2x is minus 2. Last term, differentiate minus 1, it will be a 0 because this is a constant. So then 8 times 3 times 8 times minus 3 times minus 2, you will be getting 48. Then 3 minus 2x to the power of negative 4. Okay, now lastly, integrate. So again, when you integrate, we refer to this form, the y, okay, whereby I have moved up the denominator. Now, when we integrate, our formula is ax plus b degree n dx. It will be rewriting the whole function. Remember, this function, this formula is only valid when you are integrating a linear function. Inside the bracket, it must be just linear function. Okay, so rewrite, then plus 1 to the degree, then over the new degree. And then we differentiate ax plus b is a, followed by plus c. So the reason of just linear function inside the bracket is when you differentiate ax plus b, you are getting a constant. Otherwise, this formula is invalid. And of course, the n cannot be minus 1. Okay? Or else you'll be getting the 0 in the denominator, which is undefined. So from here, I have to rewrite my 2. And for the degree of minus 2 for the function, I will rewrite the whole function. The degree minus 2, you plus 1 becomes minus 1 over minus 1. And now when you differentiate 3 minus 2x, is basically minus 2. Okay, then the minus x change to minus 1, followed by, not minus 1. You are adding 1 degree. So it will be x squared over 2, then plus c. Okay, so now you simplify this. So basically, the denominator minus 1 times minus 2 is 2. So the 2 and 2 cancel off. Alright, then left degree of minus 1. Whenever degree negative, move it down. So I will get 1 over 3 minus 2x. Then minus x squared over 2 plus c. So that is my integration. Okay, now B, find by calculation the coordinates, the x coordinates of M. So let's look at the question. Okay, basically the M is minimum point. So minimum point means dy over dx equals to 0. It is also a turning point. So since we have found the dy dx just now, I will just let this be 0. So dy dx equals to 0. That means 8 times 3 minus 2x to have negative 3 minus 1 equals to 0. So before I solve this, I will move down the 3 minus 2x cubed because of negative degree. So I change to 8 over 3 minus 2x cubed. Then the minus 1 I will move to the other side equals to positive 1. And now you need to find the x. So very simple. Just move up the whole denominator and the 1 you move it down. Okay, or no need to move down. So just move up the denominator. So which means I will be getting 3 minus 2x cubed equals to 8. And to eliminate the cube, I will take cube root both sides. So this is cube root of 8, which is 2. Okay, then from here, 3 minus 2x is 2. Move the minus 2 to the other side, move the minus 2x to the other side and the 2 to left side. So I will get 2x equals to 3 minus 2. So 2x is 1, hence my x is half. So that's the solution of the x coordinate. Now see, find the area of the shaded region bounded by the curve and the coordinate axis. Okay. So basically, here I already found it is half. That means you just need to integrate the graph, the x from 0 to half, because the region is actually the region below the graph until the x-axis. So I will just use the integration that we have found just now. Okay, so area equals to integration from 0 to half y dx. So since we have found the integration just now, just add on the limits. Okay, I'm going to copy this and ignore the plus c. So 1 over 3 minus 2x. Then minus x squared over 2. With limits 0 and half. So now replace the x by half first, which is the upper limit. 1 over 3 minus 2 times half. Then minus, okay, this is half squared over 2. Minus when the x is 0. So 1 over 3 minus 2 times 0. Then minus 0 squared over 2. Okay, so from here, the first one, basically 2 and half cancel. Left 1, 3 minus 1 is 2. So half. Okay, 1 over 2 squared is 1 over 4. 1 over 4 divided by 2, 1 over 8. Then minus 2 times 0 is 0, so you get 1 over 3. Okay, remember to bring in, but then last term is 0. So therefore, you will be getting 1 over 24. So this is the area of the shaded region. Okay, question number 11. A curve has this equation where x between 0 and pi. State the greatest and least values of y. Okay, so now since this is cos, refer to the cos graph. Okay, so this is cos 1x. Cos 1x. Now, if it is cos 2x, basically here is 2 pi. So basically for cos 2x, right, you need to draw two graphs within the 2 pi. Then now you look at here. It is from 0 to pi. That means this is my pi. Alright, this is for cos 2x. I'm not sketching 3 cos 2x plus 2. I'm just sketching cos 2x. So obviously, the greatest value is 1. Least value is -1 from 0 to 2 pi. Alright, sorry, from 0 to pi. If you refer to this part, just this part. Right, maximum 1, minimum -1. So which means, okay, for this cos 2x itself, maximum 1, minimum -1. So I will just write greatest value of y, or greatest y. It will be when 3 times 1 plus 2, because 3 is positive and plus 2 is positive. So I will get 5. So least y, that is when cos 2x is -1. Then I will get -1. Okay, done for 2 marks. Now, sketch the graph of 3 cos 2x plus 2, where x between 0 and pi. Now look at this, right? So which means when it is pi over 2, I will get the minimum point. So this is when it is cos 2x. So when you need to sketch this, firstly, we need to extend it. We need to consider the 3. Okay, that means instead of 1 and -1, now becomes 3 and -3 after I times 3 over here. After that, you plus 2. Plus 2 means instead of referring to 0, now I move up the graph 2 units. So when you move up the graph 2 units, the 3 becomes 5. The -3 becomes -1. So again, this reference line becomes 2. Okay, so I'm going to sketch that graph right now. So when this move up becomes 2, okay, so means that this one becomes -1. Alright, so basically something like this. Here is -1. So 1, 2, 3, 4, 5. That's my y. Okay, so when you look at here, right, here is pi, this is pi over 2 and pi. So let's say, now for your information, when you sketch, right, pi over 2 is basically 1.5. Let's say here 1, 2, the pi is 3.14. So that means it's like roughly, okay, here is, I will label this as pi over 2. This is pi, okay? So now, when you look at this graph, pi over 2, I'll get -1. Okay, pi over 2, I get -1. When it is 0, okay, it will be, this one becomes 5. So 0 and pi becomes 5, the y values. Okay, so then this is 2. It looks like this is a reference line. So my graph is okay, this is my graph. Right, so this is y equals to 3 cos 2x plus 2. So this is the x coordinate, x axis. Okay. Now C, By considering the straight line y equals to kx, where k is a constant, state the number of solutions of this equation for x between 0 and pi in each of the following cases. K equals minus 3. Okay, basically, when you look at this, this is y1 equals to 3 cos 2x plus 2, and then y2 is kx. Therefore, it will be number of solutions, means that the number of intersection points. When your k is minus 3, okay, when k equals to minus 3, that means you are sketching this graph. So when x 0, your y is 0. Alright, then when the x is 1, let's say, when your x is 1, your y is minus 3. So minus 3, probably here is minus 2, this is minus 3. So 1 is, okay, 1 is somewhere here. This is 1. Minus 3 is here. So now when you draw the line, okay, straight line, okay, this is a straight line. There's no intersection point. This is y equals to kx. This is y equals to negative 3x. There's no intersection point between the orange line and the curve. Okay, when you are solving y1 equals to y2, that means that will be the intersection points. So no intersection points means no solution. Therefore, 0 solution, because you need to find number of solutions. So the answer is 0. Okay, now the next one is k equals to 1. So when k equals to 1 means you are sketching y equals to x. So now again, when y equals to x means that when x is 0, y is 0. Okay, I use another point. Then when x is 1, your y is 1. So now from here, when I sketch a graph, draw a line, obviously two intersection points. This is y equals to x. Therefore, I'm getting two solutions. Okay, lastly, y equals to 3. So y equals to 3x. So when x 0, your y is 3. When x equals to 3, when x equals to 1, your y is, when x equals to 0, y is 0. When x equals to 1, y is 3. So 0, 0, 1, 3. So now I use another line. Okay, 0, 0, 1, 3. So from here, we join. Alright, so you are getting this line. Therefore, we only get one intersection point. In other words, there will be just one solution. So this is your y equals to 3x. Right? So I drew the dotted line here because I need to use that to explain. Right, so for your solution, please do not draw the dotted line on the graph because part 2 is just a graph of the 3 cos 2x plus 2. So here I'm getting one solution because of one intersection point. So that's the explanation of these three solutions. Okay, now given f, g, and h. D, describe fully a sequence of transformations that maps graph y equals to fx onto y equals to gx. So look at the gx here. Gx is f of 2x. We do not bother what is the original function of gx. It is f of 2x plus 4. Okay, now you see f of 2x is basically stretch. Okay, so it is a stretch parallel to the x-axis with scale factor half. Because of 2x, you let 2x be 1. Okay, let 2x be 1. That means your x is half. So that is the scale factor. Now, then there is a plus 4 there. Alright, the plus 4 is basically a translation. Okay, that means here I will write f2x is a stretch, then the plus 4, or probably you can just write followed by translation. So this translation, the plus 4 is the effect on the y value. So x no change, therefore 0, 4. Okay, so that means this is the transformation. So you must understand the plus 4 is a translation of 0, 4, and then the 2x here, f2x, that is the stretch to the x-axis with scale factor half. So this is the transformation. Okay, now part E. Describe fully a sequence of transformation that maps y equals to fx onto y equals to hx. So now fx change to 2f, hx equals to 2fx plus half pi. Okay, so from here, your first transformation is actually x plus half pi. Second transformation is a 2. Right? So from here, I will say that the transformation it will be x plus half pi. You let x plus half pi be 0. That means, okay, your x is negative half pi. So this is basically the translation of the x, and this is the unit. So then from here, I will say that it is a translation negative half pi. The x is negative half pi. The y, no change. Okay, followed by the 2. The 2 is actually a stretch. Okay, followed by the stretch parallel to the y-axis, because now your y will be double of the original y. With scale factor 2. Okay, so that's all for the transformation of this fx onto hx. Right? Okay, so I have completed the whole paper and also comes to the end of the video. Thanks for watching. Please subscribe to the channel and share this channel with your friends if you enjoy watching my videos, and also stay tuned for more upcoming videos. If you would like to support this channel, you can basically click the super thanks button just below the video. Okay, alright, thank you, bye.